Problem 19, Quantum Mechanics. The question is, the Coulomb potential V of R equal to minus E square by R of a hydrogen atom is perturbed by adding H dash is equal to Bx square, where B is a constant, to the Hamiltonian. The first order correction to the ground state energy is. Here in the question, the first order correction to the ground state energy of hydrogen atom is asked. The ground state wave function psi 0 is given. Now we know that the first order correction to ground state energy E01 is nothing but psi 0 H dash psi 0, where H dash is the perturbation, here it is Bx square, and psi 0, it is the ground state wave function given by 1 by root of pi a0 cube e raised to minus r by a0. Now in integral form, this E01 can be represented as integral 0 to infinity, integral 0 to pi, integral 0 to 2 pi. What is psi 0? 1 by root of pi a0 cube e raised to minus r by a0, which is the ground state wave function. Psi 0, 1 by root of pi a0 cube e raised to minus r by a0, then h dash, that is bx square. Now instead of x, write x is equal to r sin theta cos phi. Therefore bx square will become b r square sin square theta cos square phi. Then again psi 0, that is 1 by root of pi a0 cube e raised to minus r by a0. Then dτ is r square dr sin theta d theta d phi. Here r varies from 0 to infinity, theta varies from 0 to pi, phi varies from 0 to 2 pi. Now let us take the constant term outside the integral. That is this E01, that is equal to b by pi a0 cube, b by pi a0 cube. Now integral 0 to infinity, e raised to minus 2r by a0 dr, r raised to 4, e raised to minus 2r by a0 dr, integral 0 to pi, sin cube theta d theta, then integral 0 to 2 pi, cos square phi d phi. Now we have to evaluate this integral, and this integral gives the first order correction to the ground state energy in hydrogen atom. Let us evaluate these three integral separately. First, let us evaluate integral 0 to infinity r raised to 4 e raised to minus 2r by a0 dr. Now it is of the form integral 0 to infinity x raised to m e raised to minus alpha x raised to n dx. So use the standard formula. Now in the given example, we can say m is equal to 4, n is equal to 1, and alpha is equal to 2 by a0. Therefore our integral become 1 by 1 gamma 4 plus 1 by 1, that is 4 plus 1, divided by 2 by a0 raised to 4 plus 1, that is equal to gamma 5, that is 4 factorial, a0 raised to 5 by 2 raised to 5, that is 32, that is 1 into 2 into 3 into 4 a0 raised to 5 divided by 32, and that is equal to 3 by 4 a0 raised to 5. So you have integral 0 to infinity r raised to 4 e raised to minus 2r by a0 dr is equal to 3 by 4 a0 raised to 5. Now let us evaluate integral 0 to pi sin cube theta d theta. So use the standard value for sin cube theta, that is 1 by 4 3 sin theta minus sin 3 theta. Therefore the integration become 1 by 4 integral 0 to pi 3 sin theta minus sine 3 theta. Integral 0 to pi sine cube theta d theta is equal to 1 by 4, then 3 into minus cos theta plus cos 3 theta by 3 in the limit from 0 to pi, that is equal to 1 by 4 minus 3 minus 1 plus 1 by 3 minus 1, that is equal to 1 by 4 into 6 minus 2 by 3, that is equal to 4 by 3. Next, we have to evaluate integral 0 to 2 pi cos square phi d phi. This is equal to integral 0 to 2 pi 1 plus cos 2 phi by 2, and that is equal to 1 by 2 integral 0 to 2 pi 1 plus cos 2 phi, that is equal to 1 by 2, then phi minus plus sine 2 phi by 2 in the limit 0 to 2 pi, that is equal to 1 by 2 into 2 pi, that is pi. Thus we have evaluated all the integrals, and let us substitute the values to get E0 1. Hence E0 1, that is the first order correction to the ground state energy, that is psi 0 h dash psi 0, that is equal to b by pi a0 cube. There is a constant term outside, that is b by pi a0 cube b by pi a0 cube into 3 by 4 a0 raised to 5 into 4 by 3 pi. The answer is b a0 square. Therefore, option B is the correct answer.